Exercise related to electrolysis in the chemical cell. I'll discuss the whole exercise because it's a very short exercise. Um, the first question, aqueous copper 2 sulfate can be electrolyzed using a carbon electrode. Remember, when we are using the carbon electrode, like the electrodes are made up of a carbon, there is no change in the electrodes because these are inert electrode. So for positive ion, we check the reactivity. Always the less reactive positive ion will move. So if we have a hydrogen and a copper, which is less reactive, which will move? Which is less reactive positive ion.
Copper.
So copper is less reactive, so copper will move towards the cathode or the negative electrode. And for negative ion, we check the amount, but sulfate, nitrate, and carbonate never move. So if we have a sulfate SO4 and we have a hydroxide sulfate, they never move, even it is more or less, so hydroxide will move towards anode. So we need write an ionic equation for reaction at the negative electrode or cathode because the copper ion is moving. So copper is 2 plus. So how many electrons it should take? It's the charge is 2 plus. So how many electrons
Well,
it should take 2 electron and it will form a copper atom. So at cathode, the copper atoms are formed. So copper will stick to the cathode. A colorless gas was given off at positive electrode. First, because the hydroxide ion will move there, we know whenever the hydroxide ions, when 4 hydroxide ions are there, they will give O2 plus 2H2O plus 4E. That's the equation for. So means there is always an oxygen gas whenever hydroxide ions are moving. So the colorless gas, what is this colorless gas? This colorless gas is oxygen. So, and the solution changes from blue to colorless. Explain these observations. So, what is a colorless gas? So, the colorless gas is oxygen. The colorless gas is oxygen. But why the solution changes from blue to colorless? As you can see, the copper ions are blue in color in aqueous solution. But as the amount of the copper ion is decreasing in the solution, that's why it changes from blue to colorless. So what is the reason for the change in color as from blue to colorless due to decrease in concentration or amount of copper ion? So there's a decrease in copper ion or the concentration of the copper ions. That's why the solution is changing to colorless. In question 2, aqueous copper 2 sulfate can be electrolyzed using copper electrode. So what happens if we use a copper electrode? So it's a bit different from the carbon electrodes. So if we use copper electrodes, anode is made up of copper, cathode is also made up of copper, and the electrolyte is aqueous copper sulfate. So there's a copper ion, there's a sulfate ion, there's a hydrogen ion, and the hydroxide ion. Copper is less reactive, so copper will move towards cathode. But because anode is also made up of a copper, so the copper atom will go inside the solution as a copper ion. So when one copper is going out from the electrolyte at the same time, another copper ion enter the electrolyte. That's why the solution when won't change the color because the concentration of the copper does not change. So write a word equation for a reaction at the positive electrode. So at positive electrode, what is happening? We have a copper. This is a word equation we need. So we have a copper atom turning into copper ion plus electron. Because the copper atom is turning into copper ion and it's losing 2 electrons. Why the color of the solution does not change? What is the reason why the color of the solution does not change? Because, yes, Abdullah.
sir, I haven't written the equation as word equation.
No, it should be word equation because it's clearly written. So you have to So you have to write a word equation for that. If you write a symbolic equation, you will lose the marks. Why the color of the solution does not change? So what could be the reason why there is no change in color for the solution?
So electrons are moving from anode to
No,
the
no, no. Actually, the color of the solution, electrolyte. The color of the electrolyte depends on what? It depends on the amount of the copper ion, the concentration. So the concentration of the copper ion does not change in the electrolyte does not change the copper atom, the copper ions move towards cathode balanced with copper ions enter from anode. So actually what is happening that at anode, because anode made up of copper and electrolyte also contain copper. So when one copper is going out towards the cathode, another copper atom enter from the electrolyte from the anode. So as a result, there is no change in concentration of the copper ion. That's why the solution does not show a color change. And what is the large scale use of this electrolysis? You can see this can be used to purify the copper. So this is used for purification of the copper or extraction of copper, you can also say. Like to extract the copper from different substances, we can use this technique. Question 3, titanium is very resistant to corrosion. Yes, Abdullah.
There are mentioned to break down compounds into elements.
But specifically, you are right, but they ask this specifically, what is the use of this electrolysis related to copper? So your answer is correct, but the only thing which is missing, you should use the term copper there. Like refining copper, plating copper, extracting copper, you can mention that. Or converting a copper ions into atoms, that you can refer. But it should be
Wouldn't
copper,
be
should be. Because they ask specifically that large scale use of this electrolysis. Like that's specific to the question. Titanium is it clear?
clear.
Titanium is very resistant to corrosion. One of its use is as an electrode in cathodic protection of a large scale steel structure from rusting. As you can see, seawater contain hydrogen ion, hydroxide ion, sodium ion, and the chloride ion. Explain in terms of oxidation, define oxidation in terms of electron. So you will always remember from oil rig, where oxidation is a loss of electron. So O stands for oxidation is loss of electrons. The steel oil rig is cathode. Name the gas formed at electrode. Look, these are the ions present. We have a sodium ion, we have hydrogen ion, hydroxide ion, and chloride ion. And we have a cathode and anode. So which ion will move? Like this is electrolysis we are doing. So there's a hydrogen ion in the water, the seawater. Hydroxide ion is there. It contains sodium ion and it contains chloride. We want to find which will move towards cathode. This is cathode. The less reactive positive ion will move towards cathode. Which is less reactive, hydrogen or sodium?
Hydrogen.
Hydrogen. So hydrogen will move there. So name the gas. We just have to name. So we'll just write hydrogen there. Name two gases formed? Because here they did not specify us it's a dilute or a concentrated solution. So what could be the gases that could be formed? Like if a hydroxide moved towards anode, so we know the oxygen gas will be the product. If a chloride ion will move towards the anode, so then the chlorine will be the product. So what are the two gases it can form, which could form at the anode? So it can form oxygen or can also form chlorine. The next question is results of experiment on electrolysis using the inert electrode are given. Complete the table. The first line has been done for you. So we have to complete a table. Look, when it's a molten substance, the electrolyte is always used up because the positive and the negative ions are separated, so there's nothing left. That's why we say the electrolyte is used up. So first, if we have a lead to bromide, the bromine will move towards anode and lead will move towards cathode and nothing is left behind. So that's why electrolyte user. First line is done for us. The second line, electrolyte is used up. So if electrolyte is used up, what should be the state? The state should be molten. And what molten is there? Because potassium ion is moving towards cathode and the iodide ion is moving towards anode. So what is this substance? This is potassium
Iodide.
iodide. And it's a molten substance because how we identify it's a molten, as I mentioned here, the electrolyte is used up because electrolyte only used up when it's a molten substance. The next is dilute aqueous sodium chloride. So what are the, first you identify the ions which are present. So the ions which are present, it contains sodium ion, it contains a chloride ion, it contains hydrogen ion, and it contains hydroxide ion. First, the which positive ion will move? The positive ion which is less reactive, so hydrogen will move because it's less reactive positive ion. So hydrogen will move toward the negative electrode or a cathode. So what will be the product? The product will be hydrogen here. It's a dilute. Dilute means contain more water. So less chlorine and more hydroxide. So when more hydroxide, so what will happen? When hydroxide ion will move there, so what will the product?
Oxygen.
Oxygen. And what is left behind? Electrolyte, we are left with sodium chloride. So we are left with sodium chloride. But what sodium chloride? We are left with concentrated sodium chloride. Why? Because H is removed and OH is removed. So it means amount of the water has reduced. That's why we will say it will become concentrated sodium chloride. Is it clear? The next we have a copper sulfate. So it contains a copper ion. It contains a sulfate ion and it is aqueous. So hydrogen ion and the hydroxide ion. The copper is less reactive, so copper will move towards the respective electrode cathode. So at this time, we will have a product copper. Sulfate never moves, even it is more or less, so hydroxide will move there. So when hydroxide will move there, the product will be oxygen. And what is left behind? Because hydrogen and sulfate left behind, when hydrogen and sulfate left behind, it's called sulfuric acid, which is H2SO4. So what will happen to the electrolyte? The electrolyte will be sulfuric acid. Hydrogen sulfate you can also say, but sulfuric acid is the name given to H2SO4. Now, what are the ions here? We have like hydrogen is moving there, bromine is moving there, and potassium and hydroxide. So means this
Potassium
contain good. It contain potassium means it is a potassium and bromide, and it is a hydrogen and hydroxide from water. So it's actually
Aqueous concentrated potassium.
potassium bromide. That is first thing we identify. Then it is aqueous, and whether it is a dilute or concentrated, because the bromine is moving there, so it is aqueous concentrated potassium bromide. If it was a dilute, then at this point we'll not get bromine, we'll get oxygen if it was a dilute. But if you are getting a salt there, it means it is a concentrated. The next is the zinc oxide is reacted with sulfuric acid to give zinc sulfate. This is electrolyzed using inert electrode, so which contains zinc, sulfate, hydrogen, and hydroxide. Zinc is formed at negative electrode cathode, so we have to write equation for zinc. When zinc is there, 2 plus, it should take 2 electron and it will form a zinc atom. Write an equation for reaction at positive electrode or anode. We know sulfate nitrate never move. So hydroxide will move there, and whenever 4 hydroxides are there, it will be O2 plus 2 water molecule plus 4E. The electrolyte changed from aqueous zinc sulfate to, so because zinc is used up, like zinc is removed according to the question, and hydroxide is, so what it will become? It will become a sulfuric acid. Then the electrolysis of a concentrated aqueous sodium chloride. So complete an ionic equation. So here, what will the ionic equation? Hydrogen ion plus E become hydrogen gas. When 2 hydrogen ion plus 2E give hydrogen gas. And here what happened? The chloride ions are there, loses 1 electron from chlorine atom. When 2 chloride ions, they will lose 2 electron and it will form a chlorine gas. So chlorine is removed and hydrogen is removed. So what we are left with as an electrolyte, Na and OH, so it will become sodium hydroxide. So why the solution changes from sodium chloride to sodium hydroxide? So we will say the hydrogen and the chloride ions are removed from the electrolyte. The H ion and the chloride ion are removed from the electrolyte or discharged. That's why the solution turned into sodium hydroxide. Question 6, the copper oxide is reduced to copper, which is then refined by electrolysis. Label the diagram apparatus. If we want to refine, anode should be made up of impure copper. Sorry, this is the anode, the right. So this is an anode. Anode is always made up of impure for extraction. This should be a copper salt like aqueous copper sulfate, you can say. Any soluble salt, and this should be pure copper. Why it is like this? Because what will happen? The electrolyte contain a copper ion. So when copper ion will move towards the cathode, the copper atom go inside the solution as a copper ion. And the impurities means the substances which are not part of the copper will left behind. That's how we do separation or purification of the metal. Give one use of a copper other than making alloy. So what we can say other than the alloy, we can say copper can be used for wires. A chemical cell, a cell will change dash energy to electrical. So the cell is actually removed from the syllabus. This topic about the cell is totally removed from the syllabus. It was there before 23, but not now anymore. So, but the answer here, the cell will convert the chemical energy to electrical energy. And draw an arrow on the diagram. So how electron will move? Electron will move from negative to the positive. But this topic is removed from the syllabus, like the cell. Only electrolysis is there, but not the chemical cell. Then the second method to make a steel, if you want to show an arrow for electrolytic cell is there. So from a supply, the electron will move out towards the cathode and electron will go towards the positive terminal. Like whenever we have a battery is there, positive and negative. So the electrons will move from negative terminal towards the cathode. So majority of the electrons are here and electrons will move out from the anode. So majority of positive ions here. So we just have to show, but the cell is removed like the previous question 8 is actually not part anymore. Is it clear, this exercise?